Welcome to the Cisco Live demonstration of the OpenStack Deployment in the Enterprise session that was covered in Orlando in 2013. So we are recording this demonstration again for a couple of reasons. The first one is that there were some technical difficulties with the demo machine I was using in Orlando, and it did not get captured in the session video. The second is that several people that did not get to attend the session, or did but wanted to better share some of the demonstration with their colleagues, were asking for basically an easier place to gain access to just the demonstration itself and not the 2-hour-long video. There is some background to what we're going to walk through, because the demo itself is very simple and quite quick, but you do need to know what it is that we're trying to show. So I would encourage you to go to CiscoLive365.com. If you don't have an account already, create one. It's free. And do a search catalog entry for BRK DCT 2367. And you will arrive at this page. And this is really the details of the session that we had in Orlando, kind of covering this topic. So grab the PDF that's available there, and that will kind of give you a little bit of background of what it is that we talked about. If you have 2 hours to waste of your life, then you can also watch this session video of my explanation of those slides. But what we're really setting the stage for in this demonstration is that historically in Folsom and even previous versions, we really had some good functionality in the OpenStack Dashboard, but not all of the functionality that we may need to build a system, kind of from scratch, from an idle OpenStack environment, build our networking, build our, upload our images and so forth. So we kind of walked through where we could do part of that graphically in Folsom, but part of the networking, for example, we had to do by hand. Well, in Grizzly, we inherited a lot more functionality in what was formerly called Quantum, where we could build subnets and routers and link all of that together and actually launch instances. So that's kind of what we're going to walk through here in this quick demonstration. So as a part of that, we walk through, what do you do to build a public network and a private network, and what do you do when you're wanting to do a router inside of your OpenStack environment. A lot of that stuff was covered in that session. We're not rehashing that in this demo. So what we've done from a bit of pre-work to save us time in this demo is we've built this basic topology. We've got a public network glued together by a router with this private network that we're going to attach some instances to. I also uploaded a new Ubuntu Precise image that we're going to spawn our images or instances from. I went ahead and modified the default security group and allowed port 22, port 80, and ICMP or ping in this case to be permitted into our environment. So what we're going to do is we're going to spawn some instances, and really what our goals are here is we're going to attach a couple of instances to this private network. We're going to run a very basic web service on both of them, test that out. Then we're going to go into the new load balancing interface and establish a load balancing system or service that is going to front end those web servers. Okay, so you and I, historically, this would be like a no-brainer to do, in your favorite F5 or Citrix NetScaler or whatever, and it's just a basic web service. But a lot of this has not been very well documented as a procedure or even an example process in the OpenStack community. So people that run a different system may not know that it's actually this easy to get the same thing running in OpenStack, and that's one of the other reasons why we're going through this. Okay, so let's launch a couple of instances. We're going to select that precise image, just call this Web 1, and I've got a lot of stuff running on this demo system that is being used by other people, so we're going to use very little flavors here. The only key pair that exists is by default, and this security group by default. So there's no other choices, so that's easy enough. And we're going to select this only private network that we have to attach to. Okay? So that one's spawning. Let's spawn a second one because we are going to do load balancing, so we're basically going to do the same thing over again. Again, all that stays the same, and attach this private network. Okay, so both of those are rolling. Let's take a look at our network topology now. Okay, if you've not looked at the network topology screen before, it's very graphically very simple, and it should be. And you can click on any one of these objects, and it will actually drill down to the next level. So we can click on, for example, this web server, and that will take us to this instance overview with all of the parameters that we hopefully had defined for it. We can take a look at the boot log, and we can even run a VNC console from this box. We can see that it's still booting, and now it's available if you didn't want to SSH or do some other kind of interface to it. Okay, so let's get back to our network topology view, and we'll keep this in this top pane here while we jump into our test node here, our jump box, to make sure one that we can run this system, and then we'll bring our applications online and so forth. Okay, so in this example, we're not running IP namespaces, which we talked quite a bit about in our 2-hour breakout session. So if you don't know about Linux IP namespaces and how it's used in some forms, in the OpenStack world and overlapping IPs and so forth, then you need to go read about that. But in our case, we're not running IP namespaces, so our jump box has direct access to each of these nodes. So we should be able to ping it because we have the security groups opened up to do that. Cool. So we can get to that. So we're going to run 3 SSHs. 2 of them are to one node, and we're going to run our service on one, a TCP dump on the other, and then we'll run a third SSH to our second node. Okay. So let's spawn that, and then we'll connect into this one. Okay. So now we've got these running. Okay. So the first thing we're going to do is we're going to build a little index file so that when we do our round robin, that when we know we get our gets against them, that we're actually responding appropriately between both nodes. Okay, so we're just going to do a quick index file here. And then we'll label it. Okay. Okay, and then we're going to run a Python module. Instead of doing Apache or Nginx or something, we'll just do this, and that will get us a basic web server up and running. And then okay, and we'll use that one as well as a means to test some of our load balancing stuff as well. Oh. Typing sucks today. Okie dokie. Okay, so now we're listing on all of them. So now we can come back to our jump box here and connect to each one of them. Okay, so we can get to that box. So that address aligns with that index file, and that address aligns to that index file. Cool. So now let's get started on our load balancing, okay? So we're going to come into this load balancer interface, and we're going to build a pool. Just call this web pool 1. We're going to select the subnet and the protocols. And in this example, we're going to just run round robin. Now we've got to assign a VIP to the pool that will front end these member servers that we're going to assign, okay? And so now we're just going to call this web VIP 1. And we're going to pick an address for the VIP out of this pool, and we'll talk about how you represent that on the internet or externally as well. And then there's protocol port, HTTP, whatever. We're not messing with session persistence, and we're just going to do an unlimited value. So this protocol port, obviously, we know that we don't have to run the same port on the VIP as we do the backend. For example, when you're doing SSL offload, you may do 443 on the VIP, listening to the client connection, but you're actually communicating in clear to the backend web server on 80. So this interface is laying the groundwork for future functionality of the load balancing service. Okay. Okay. So now we've got our VIP. Now we have to attach members that we're going to front end, okay? And so we're going to select that web pool that we just built, attach our two instances. You can read more about weights and so forth. And then our protocol. Okay, so now we have all the makings for doing real load balancing. So now we're going to change our wget to the VIP address. And so hopefully we'll round robin between each of these nodes. So now we can see web 1, web 2, web 1, web 2, web 1, and so forth. Okay, so we are doing round robin. And we can see on these there's our first wget directly to the node, and all of our subsequent wgets were actually through the VIP. Okay, and then we can see TCP dump has been capturing that and then serving this stuff out of that index file. Cool. And the same thing is happening on this box. Okay, so now the final thing that we're going to show from the load balancing perspective here is we're going to go in here and show our monitor. So what we're going to do here is we're going to clear a few things so that we're going to start a fresh TCP dump. So everything that we get from here on out on this little test, we're going to be hopefully seeing from this monitor we build. Okay, so we're going to select the pool. There's various types of monitoring. Obviously, I'm not a big fan of ping alone, obviously, because the service dies but the node is still alive. Now you're forwarding traffic to a box that can't respond to it. So in this case, we're going to do an HTTP. You can play with your favorite delay, timeout, and retries depending on the sensitivity of the service you're running. Here's the get, and then we're expecting a 200 if the service is alive. Okay, and if we don't get that 200 for that particular member server, then we're going to go in through our timeout procedure and retry procedures and so forth, trying to figure out when do we take this box out of rotation, and then how many times can we get successfuls through our retries to bring it back online once the service gets restored. Okay, so now we're going to do an add, and now we're going to see on our environment here at about every 5 seconds this thing is going to send a monitor, a get 200 basically, against this node. And as long as we're getting this 200 within the intervals we expect it, everything is hunky-dory. Okay, and so now we've got a monitor running against both of our nodes. Excellent. So the final thing we want to show is great. We've got these two web servers running their web service, and we've got a VIP, which in the future will be represented in the network topology screen. Today it is not yet there on 254. But how do I expose that 10.0.0.254 to the outside world to establish connections? Well, if this were a provider network or something else, you might be running out of public space. You might be running a public space range or be doing NAT in a firewall or load balancer upstream. In our case, we're actually running a NATed environment through this this quantum router interface. Okay, so we're going to run floating IPs. So we're going to go back into our access and security screen, go to our floating IP environment, and we're going to allocate an external floating IP out of our public pool range. Allocate that to be used. Okay, so now you can see we're not in the public private range, we're in that public range, that 192.168.80 space. Okay, but we've not assigned it, so we're going to associate that floating IP that's available to us, and we're going to select a port to attach it to. Okay, so we can assign it to each one of the web servers, or we can assign it to the VIP, and in the future it won't say none, it will actually represent the actual load balancing service. So we're going to say 254. Okay, so we've now associated that. Now an external system can now access that by getting to it on its public range. Although we're running a private range, it is public to this system. Okay, and so now we can do a load balancing web 1, web 2, web 1, web 2 in our pseudo outside world. Cool? So that was a kind of a quick walkthrough with us kind of looking at the new load balancing service functionality that is available in Grizzly, but also exposing additional functionality that we have in the OpenStack Dashboard that we didn't have available to us, for example, in Folsom. So this shows a nice progression that not only is the feature support and the CLI support that goes along with that, but we also have the dashboard being updated through Project Horizon to enable graphically those new feature sets as we move from Folsom to Grizzly to Havana and on we go. Okay, and so hopefully this kind of gives you a little bit of a snapshot of some of the things that you can do graphically via your tenant admins and so forth from the Grizzly release. Thanks and have a great day.